now then.
Hello, Neural Network listeners. My name is Vasu, and I'm accompanied by my co-host, Arman
Armand.
Priyadarshan. And today, we're interviewing Dr. Zick. Would you like to introduce yourself?
Yes, of course. Thank you for having me. My name is Yair Zick. I am an assistant professor at the University of Massachusetts Amherst in the Manning College of Information and Computer Sciences. Um, and my work is generally in the space of economics and computation, which means studying economic problems through an algorithmic lens. So designing algorithms that can come up with solutions using ideas from economics, game theory, fair division, in order to guide kind of as principle, guiding principles for the algorithm's objectives. In addition to that, I also work on algorithmic transparency, which means very broadly, well, given some kind of a predictive system, so think like maybe binary classification or something like that, how do we explain the decisions of that system to different stakeholders? And when I say stakeholders, that could mean very different things from programmers trying to understand the system, if it's large and complicated, to end users, to maybe legislators or other stakeholders that are involved in the algorithmic decision-making process.
Mm-hmm. Could you share some highlights from your research journey or areas that you find like the most exciting?
Yeah, sure. I think in terms of research that I've done that I thought was very nice and interesting, um, we've had um, some interesting results using, again, ideas from game theory, in this case, cooperative game theory, in the design of automated systems for explaining the decisions of machine learning models. So just very briefly, the idea is that we treat the different features that a model uses as players in a game, and then you can think about every subset of features as having a certain value, right? So in this case, the value of a subset of features roughly corresponds to, well, how important was that subset of features in the algorithm reaching its decision, right? So you have this like complicated function because it's for every single subset of features. So you can think about it like if there's like 20 features, then we're talking about 2 to the power of 20 subsets. And then what you do is you take all of these values and you try to aggregate them into a single number that corresponds to how important was a specific feature. So how important was your age, your height, your weight, whatever it may be, to the algorithm's decision about you. And it turns out that there is a specific way of doing it that is called the Shapley value. Doing some analysis on this, we could show why this type of approach makes sense, and we published a paper about this, and that was back in 2016. In terms of other fun things that we've worked on, we've had a few works that were on a fair allocation of resources. One of the things we looked at was fair rent division. So you can think about roommates, all of them sharing an apartment, and then, well, they need to decide who goes to which room, like which person, occupies which room, and how much rent they're going to pay for it, right? So we came up with an automated tool that helps you make that decision. So the idea is that each one of the roommates submits to the algorithm, well, how much rent do they think that should be charged for each one of the rooms, right? So if there's, let's say there's 3 roommates, then like for room 1, I think it should be $400. For room 2, I think it should be $500. And for room 3, it should be $200. So, I'm just making up numbers. But the idea here is that this corresponds to how much you think this room is worth, right? And then using, well, an algorithm, we come up with a way of saying, well, which person gets which room, and also how much rent they should be paying. And the fun part here is that we, in addition to coming up with these algorithmic results and doing some analysis, we also ran some experiments. And in those experiments, what we did is we basically, this was again back in 2016, and at that time, the New York Times has published an article about this system, Split It, and we had a chance, because a lot of people subsequently use the system, we had a chance of looking at all of these people that we had, like tens of thousands of people who use the system at roughly the same time, and we can use that to test the efficacy of our algorithm. And then we kind of emailed, well, not all of these people, but a subset of these people that we decided were real users using some parameters, and we emailed them and we basically asked them to compare the new system that we came up with the old system that was running on Split at the time, and then argue, well, hopefully convincingly, that indeed this was a useful improvement to the algorithm, and indeed this is what's running on this website right now. And in terms of slightly more recent work, we've been working in the past couple of years on ideas surrounding allocation of indivisible goods. And here we had two test cases that we're working on. One of them is reviewer assignment. And when I talk about reviewer assignment specifically, I mean, in the context of computer science, the way things work is that, well, let's say that I wrote a paper, right, with maybe some colleagues, and now I want that paper to be published. So what happens is that in computer science, there's a bunch of conferences that I could choose from to submit my work to, and then I will take this paper, I will submit it to a conference. And I mean, of course, I'm not alone. Like large computer science, specifically AI and machine learning conferences, could have tens of thousands of submissions. So you have this very large set of papers that, all of them need to be reviewed. And the conference, well, they prepare for this, and they have what's called a program committee. So this is basically a few thousand reviewers that are supposed to review these papers. Now, this is a challenge because you have this matching problem, right? Where on one side of the market you have papers, on the other side of the market you have reviewers, and well, not all reviewers are qualified to intelligently and effectively review all the papers, right? So I, for example, am not qualified to review a paper on computer vision, right? Even though I am in the field of AI, I am not an expert in computer vision. So it would be a bad idea to give me to review a paper on that. I am qualified to review on a lot of other topics. Again, like, resource allocation, game theory, computational complexity, things like that. I'm fine, but not for that, right? So how do we match reviewers to papers in a way that makes sense? And we came up with an algorithm that did this, and it actually got deployed in one of the biggest platforms for computer science review called Open Review, which is also based here at UMass. So that was really nice. And also now we're working on fair course allocation. So think you're going to a university, the university offers all of these classes. Who gets to go to which class, right? So the system that underlies this is quite important because it needs to ensure that students are treated fairly on the one hand, and on the other hand, that students get the classes they want, that it's efficient, that there's a whole bunch of considerations. And specifically, what makes all of these systems interesting to me is the fact that these are markets without money. And what I mean by that is that those markets, we cannot use money in order to solve them, right? So if you think about, like, I don't know, you're going to the supermarket and, there's nobody sitting in the supermarket and says, well, okay, we need to figure out who gets the tomatoes, who gets the peppers, who gets the cucumbers, who gets the bread, right? That's not how it works. There's a price mechanism in place that says, well, if you want to get tomatoes, that's absolutely fine. They're going to cost you so and so per pound, and cucumbers and whatever, right? And if prices go up, people presumably don't buy so many tomatoes, and if prices go down, people buy more tomatoes, and also signals to, well, the tomato producers that, well, we need more tomatoes. If prices go up, then it creates an incentive for people to produce more of that resource. And in universities, right, we don't have that system in place, right? You don't, I mean, for many very good reasons, we're not saying to students, well, if you really want to take introduction to algorithms, well, you gotta pay this much more in tuition in order to get in, right? We don't do that, so we have to work with these centralized mechanisms instead, and I think that's quite interesting.
Yeah, I think the concept that you mentioned about like the markets without money is pretty interesting. And also like I just wanted to get your perspective on this. Like what do you think, what do you define as like fair? Or like yeah.
That's really a core question here, right? And there's many different concepts in the literature. So the great thing is that I don't have to define it, right? All we need to do is to read literature in economics, and there's a lot of really like good, well-established notions of what fairness means. But very broadly, you can think about fairness from the perspective of an individual, and you can think about fairness from the perspective of a group of people, right? So from an individual, you can think about roughly two ways of thinking about it. One key concept of fairness for an individual is the idea of envy. So what do I mean by envy? Is, well, if I look, let's stick to the, let's say, course allocation example. If I look at the set of courses, now I'm a university student and I got this set of classes assigned to me this semester, right? And I look at the set of classes that Arman gets, then I would be envious of Arman if I prefer the set of classes that Arman got to the set of classes that I got, right? And that's undesirable because then, well, I might feel upset because, well, Arman got better stuff than me, and I'm like, why is that right? Maybe I'll write a complaint letter or something like that. And that's a pretty fundamental concept of envy in economics, or rather of fairness in economics. Another notion is what's called a fair share guarantee, right? So you can think about this as saying, well, for each individual, we can look at their preferences over items and we can try to compute how much welfare or how much utility they deserve, right? And there could be some really, really simple computations. For example, you could say, well, if I gave, Yair access to all the classes, right? Then, and I just gave him all the classes, what would be his utility from that set of all classes divided by the number of students, right? So that would be one notion. It's called proportionality, right? And it's actually a pretty fundamental notion. Another notion is called the maximum share guarantee, where you can think about this. It's easy to think about it with two people, but it generalizes nicely to many people, right? So let's, think about the idea that we have two people, and now we have a bunch of items, right, on the table, right? And then when we want to compute the guarantee or the welfare that I'm entitled to, what would happen is that you would let me partition the items on the table into two bundles, right? But then I get the utility of the worst one, right? So think about it like, well, from my perspective, what I would want to do is I would want to distribute the items into two piles that are, for me, approximately of the same worth, right? And then the value of the worst one of the two is what's called my maximum share guarantee, right? And if we have more people, then it's basically distributing it into the commensurate number of piles, and then I pick the worst one. So that's what's called a fair share, maximum share guarantee. And from a group perspective, you can think about different notions, but you can define ideas of, for example, if I have some kind of a well-defined group, you can ask yourself, well, you can talk very similarly about ideas of, for example, envy. You can also talk about um, ideas that correspond to a stability of the system, of basically saying to a group something like, well, maybe this is what you got, right? So you think about, like, for example, if we're talking about students, you can think about the group of all seniors or all of the economics majors or something like that, right? You could tell them, well, look, this is this as a group, this is the welfare that you got, right? Do you think you could have gotten better? Right. And then you need to ask, well, what do you mean by could have gotten better, right? I mean, of course, if you just gave like the economics majors like free reign of like whatever classes they could have gotten, like ignoring the needs of other people, then of course it's not that obvious what's going to happen. But if you define it carefully enough, you can talk about that. And that's also ideas of a group fairness here.
Yeah, it makes a lot of sense. And also, I think the concept of envy, one of the questions I was going to ask later was like, what is envy freeness? Is that term popped up a lot in your work? But like based on the answer you gave, I'd assume now that it's just like an outcome where like nobody feels that they got a share that's like not as good as someone else's, and thereby they don't envy people. Is that kind of what that means?
Yeah, that's basically what it means. I mean, if you have siblings or a parent, you know exactly what I mean, right? You can think about, like, like little kids trying to divide toys between them, and if each one of them gets a pile of toys that they like more than the pile of toys that their sibling gets, then they're okay. Otherwise, you get into fights and, like, why do they get all this stuff and why don't I get anything nice and all these ideas, right? The problem with envy freeness as a concept, even though it's obviously nice, is that it's not guaranteed to exist, right? And the easiest example of that is, well, what happens if there's only one item and three people, right? Well, somebody's going to get it, right? And then obviously, inevitably, the other two people are not going to be happy about that, and they're going to envy whoever got the item, right? So that's a challenge. And then in the literature, like, people came up with these ideas of, I'm talking about people like Eric Budish, Lipton, Markakis, and Mossel, that came up with ideas of what's called envy freeness up to one item, right? And here the idea is, okay, well, you look at person A and they look at their stuff, and then they look at the stuff that person B has, and then person B would go, well, they look at it and say, well, actually, I do like person B's bundle more than mine. But if person B just throws out one of their items, then I stop envying them. Then I'm good, right? So the idea here is to have these kinds of approximate envy freeness notions, and those actually do exist, which is really nice, because then that means that, well, that opens the door to us saying, well, can we come up with algorithms that actually compute these approximate envy freeness notions? And there's a whole story here, but yeah, that's where things are. Yeah.
No, I agree with Armand. I think it's like very interesting how you're looking at markets without money. Because when I first heard you mention the term economics, that's where my brain went automatically because I immediately pursue economics as money. But hearing
Yeah.
like this very interesting different circumstance, it's like opened my eyes to like freeness and like fair, like what's fair inside society. So that's
Yeah,
pretty cool as well.
and I mean, the markets without money. I mean, I'm not the first person to study them. I think that
Mhm.
probably the biggest example of those are works by, well, Nobel laureates, David Gale, Lloyd Shapley, and Al Roth. That, well, they worked a lot on these amazing matching markets. If anybody has ever heard about the term of the Gale-Shapley algorithm for matching in two-sided markets, I mean, that's probably the most famous example of these amazing algorithms for markets without money. And here again, David Gale and Lloyd Shapley kind of thought about this market in the context of a matching market between men and women. Um, where you have on one side of the market you have you have men and you have women, and you want to match the men and the women, and each side has preferences of where who they like the most, and then how do you come up with an algorithm that computes a matching between the two sides in a way that satisfies certain ideas of stability. And here stability simply means that, well, if you look at a pair of people and that are not matched to each other, then that pair of people who are not matched to each other, they cannot just kind of break the match. And by break the match, I simply mean that, well, if, person A, like a man A, is matched to a woman B, then is rather not matched to woman B. It cannot be the case that both man A prefers woman B to whoever he's matched to, and woman B prefers man A to whoever she's matched to, because then they could just, well, match with each other and then break the matching, and then kind of like the whole thing unravels, because then like the unmatched people, the newly unmatched people, will now start looking for other matches, and that would be very bad. So Gale and Shapley's results shows that, well, such a matching, a stable matching is guaranteed to exist, and they actually came up with a really nice and neat algorithm for that. And later on, that algorithm was implemented in matching doctors, residents, medical residents to hospitals in the National Residency Matching Program. There's also been really amazing work on kidney exchanges. That has been extremely influential and impactful in a real ways. I mean, like in the sense of saving lives. So this is just a really interesting market without money. And again, in kidney exchanges, the idea here is that, well, we have kidney patients. So as I'm sure we all have two kidneys, but once both of them stop functioning for whatever reason, usually disease and stuff like that, then things get really, really bad, because like your kidneys filter out your blood, they clean it out from like bad stuff. So you gotta have your kidneys, at least one, to survive. And once you don't, you have to start going through dialysis, which is a really unpleasant process. It's painful, it's tiring, it's tedious, and people don't want to be on dialysis for a very long time. So the only other option you have is to get a healthy kidney from somebody. And there's, well, two sources generally, and one of them is from a deceased donor. So if you sign, when you get a driver's license, you sign like a thing that says that you're willing to donate your organs. Then yeah, when if unfortunately you pass on, then you can potentially save somebody's life by donating your kidneys if they're a match. And the problem with that is that, well, the supply of deceased donor kidneys is declining. Well, frankly, because just our world has become safer, so people don't pass on from accidents that much. So at a young and healthy age, and that then their kidneys are not available to be donated. And also because just on the demand side, right, we have just an aging population. People just are sicker, kind of like at the older ages, so they just need more kidneys. So the only other alternative is what's called a live donor, right? So in that case, you have a loved one, a friend, spouse, child, whatever it is, that is willing to give you one of their kidneys. Which is, the ultimate gift, right? Like literally giving one of your organs to someone else. That's amazing, right? And then what happens is that, well, maybe you think about, like, you have a pair of people, one patient, one donor. The problem is that, just biologically speaking, not everybody can give a kidney to everyone else, right? So we have to be a match, right? So the most I'm not that kind of doctor, but like my understanding is that there needs to be a match in terms of blood type, but that's not the only thing. There needs to be other things that are in play to make sure that, like, your the host, like the patient, will not, their body, their immune system will not reject the organ, right? Because then, well, the surgery, like, the person will get very, very sick, and of course, in particular, the organ will stop functioning. The kidney would stop functioning. So you have this pair of people, and you may have many pairs of such people, right, who are just waiting to get a deceased donor, but like they do have a willing donor, live donor, that's willing to give them a kidney, but they're just not a match. That's unfortunate. So what the big idea here, which was really amazing, was that Well, you can take a pair of these people, like a patient donor A, and patient donor B, and you can say, well, okay, A's donor is not a match for the A patient, but they are a match to the patient B. And similarly, the donor B is a match for patient A. So then you can do an exchange.
Yeah.
And you can do it with actually more than two people. You can think about like you can create like a cycles of these donation cycles, and you can have several people participate in one of these. So then it also creates a lot of really interesting computational challenges, because well, what happens? How do we basically take this graph? Think about like a really complicated graph, and where there's kind of like a line from a pair one, or pair A to pair B, if they, or rather, like if they can do this kind of a donation, like if donor A can give a kidney to patient B, right? So there's a line that connects them, and then you basically want to cover this graph with a bunch of circles, right, of these donation circles in a way that maximizes the number of people that get matched to each other. I mean, there's a lot of other technical challenges here. This is not my work, just to be clear. This is, Al Roth and many other people have been working on this, and but I'm just pointing out that the field of market design without money is quite rich, and interesting, and there's a lot of really high impact and interesting work here.